Now, one last thing that we have to talk about in regards to similarity is a theorem about their perimeters. So this theorem states that the ratio of any pair of corresponding sides of similar polygons is equal to the ratio of their perimeters. Now, it's really important that you remember this theorem because you will be using it throughout this chapter, and very often people forget about this theorem and they feel that they don't have enough information to complete a problem. So let's take a look at this example because it kind of goes with this theorem, but make sure you're kind of looking out for that. And the key word should be anytime it's asking about the perimeters of similar polygons, that's when you know that you have to use this theorem. So we're given that triangle ABC is similar to triangle FED, and it asks us to find the ratio of the perimeter of triangle ABC to the perimeter of triangle FED. So the first thing I said back at the beginning of that first video is anytime you're given similar polygons, start by writing the extended proportion. So I'm going to go ahead and do that now. I know that AB corresponds to FE. So I know the ratio of those sides is equal to the ratio of BC over ED, which is equal to AC over FD. Now, by the theorem we just talked about, we know the ratio of the perimeters is going to be equal to the ratio of any corresponding sides. So I'm going to look to see if I know any of those three ratios, if I know AB over FE or BC over ED, or AC over FD, because then my job is done. So AB, we do know AB is 3, and FE is 2. So I'm done. That's a pair of corresponding sides, and I know the ratio of the perimeters is equal to the ratio of their corresponding sides. That's your final answer, 3-2. Make sure to be careful too when it asks for a ratio, make sure that your final answer is written as a ratio. So we're going to try the next 3 examples that have to do with similar polygons. Some of these are similar to homework problems that you'll see or problems that you'll do in class. Okay, so in example 1, we're given that triangle PQT is similar to triangle RQS and that SQ is equal to 2x plus 1. So again, the first thing that you always want to do when you're given similar polygons, write out the extended proportion. So do that now. So there's the extended proportion that you should have, and then the next step, step 2, would be to fill in everything that you know. So PQ, we're given that's 4. RQ is equal to x plus 2. QT is equal to x minus 3. QS, that was one of our givens, 2x plus 1. And then we don't know anything about PT or RS, so I'm not even going to fill that in. So notice now that I have a proportion that I should be able to solve since there's only one variable. So next step would be to go ahead and cross multiply. So when I cross multiply, I get 8x plus 4 is equal to x squared plus 2x minus 3x minus 6. Don't forget when you have something like this, a binomial times a binomial, you have to FOIL it. That's one of the biggest mistakes that I see is people not FOILing. So now from here, let's go ahead, since it's a quadratic equation, and get all of our variables on one side of the equation and kind of combine some like terms. So when I clean my equation up, I get x squared minus 9x minus 10 equals 0. So now I need to see if I can factor this. And I can factor it, so I get x minus 10 times x plus 1. And when I go ahead and solve this for my 2 answers, I get x is equal to 10 or x is equal to negative 1. Now let's look and see what the problem is asking us to find. It's asking us to find the length of ST. So because we're not specifically given ST, we're going to have to probably plug it into both SQ and TQ. So right away, when I go to plug in these two answers into SQ, one of them does not work. The negative one does not work, because then that would give me a negative length for SQ, and I know I can't have a negative side, so it can only be the 10. And when I plug 10 into SQ, I get 20 plus 1, so that would be equal to 21. When I plug in 10 into QT, I get 7. And I know that ST is just going to be a matter of subtracting the two. So 21 minus 7 is 14. And that's your final answer for the length of ST. Moving on to example 2, this is slightly different, but same sort of idea. It says triangle PMQ is a dilation of triangle OMN. What is the enlargement ratio? And find the length of PM. So because it's a dilation, that's just another way of saying that the two triangles are similar to each other. So I'm going to start by setting up the extended proportion. After I set up that extended proportion, let's go ahead and fill in what we know. And because we don't know what PM is, I'm going to just call that X. OM is 4. MQ would be 6. MN would be 3. And we don't know anything about PQ or ON, so I'm just going to leave those blank. Now, it asks what is the enlargement ratio. So right away, I know the enlargement ratio is just equal to their corresponding sides. 6 over 3, always reduce your ratios. That would reduce to 2. Now, is 2 a ratio? No, it is not. So make sure you write your final answer as 2 to 1. So that would be the enlargement ratio. Now, to find the length of PM, I'm just going to solve this proportion. So you can go ahead and cross multiply. So you get 3x equals 24. When you go ahead and solve for x, you get it's equal to 8. And x is the length of PM. So that's your final answer for the length of PM. Now this last example has two quadrilaterals. Quadrilaterals, similar quadrilaterals, and actually, this should say that they are actually similar to each other. So if they are similar, again, their corresponding sides line up. For quadrilateral, instead of having 3 ratios, you're going to have 4 ratios. AB corresponds to side EF. And right away, if I think back to that theorem we just talked about, we know that the ratio of their perimeters is going to be equal to the ratio of any pair of corresponding sides. And right away, looking at my diagram, I know what AB and EF are. So I know the ratio of their perimeters would be equal to 6 over 9, and then I can reduce that even further by dividing both of them by 3. So the ratio of their perimeters is 2 to 3. Done. So hopefully now you have a better idea of some of the different types of examples that you'll see with similar polygons, and now you should also have a better idea of the definition and how to set up an extended proportion.